All right, so we're going to graph trig functions sine and cosine today. And we're going to kind of look at the parent functions like we normally do for Algebra 2 and Algebra 1, and then we're going to talk about like what transformations happen and what does that look like in terms of the graph then, okay? So your unit circle is over here on the right-hand side. So if I asked you something like, what is the sine value at pi over 6? What would you tell me the sine value is at pi over 6? 1/2. Sine is my y value, right? What would the sine value be of pi over 2? 1. What is the sine value of 7 pi over 6? -1/2. Okay, so for the first part of this of these notes for the graph, we're going to look at all of the y values and what does that look like when we draw it on an xy coordinate plane, where my x value is actually going to be my angle. So like my x value is going to be pi over 6 or pi over 2 or 2 pi over 3. And then I'm going to plot the y value of the point on the unit circle, okay? So I'm going to make a little note here. This x value is actually your angle. And similar to like when you were graphing things in Algebra 2, you guys did like -2, -1, 0, 1, and 2. Those were kind of like your 5 main points that you plugged in a lot of the times. Our 5 main points that we're going to plug in are going to be the points that are on your x and y axis here. So we're going to plug in 0. We're going to plug in pi over 2. We're going to plug in pi. We're going to plug in 3 pi over 2. And then I'm also going to plug in my 5th point. This is going to be 2 pi. Okay? The reason we do that is because my x value and my y value at these points are nice and even numbers. Okay, they're not fractions, they're not radicals, they're not square roots or anything like that. So those are the 5 points that we're going to plug in on our x values here. So I'm going to plug in 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and now if we plug in that x value into this function here, we have sine of 0 is my y value. So sine of 0, if I go back to my unit circle here, sine of 0 is going to be 0. We agree? If I go to pi over 2, sine of pi over 2 is 1. Sine of pi, my y value at pi is 0. Sine of 3 pi over 2, 3 pi over 2, my sine value, my y value is -1. And then sine of 2 pi, my y value here is also 0. Okay, does anyone know what the sine graph looks like? Yeah, it's squiggly, right? Like it's like a little wave, okay? On that little wave, does it ever stop? No, it goes forever and ever in both directions, okay? So when I plot these points on here, and like when you do this on the test and the quiz, it will just be an xy coordinate plane. Sometimes it might not even have the x and the y like lines on there, so you might have to draw them in. But the most important thing is that you are labeling the coordinates on your x value and the y value, okay? You will not have to create an xy table. If you want to do that, you can if it helps you. But what I will be looking for mainly is, did you graph it correctly, okay? So on the x-axis here, I'm going to label my 5 coordinate points. So this would be 0, and then I'm going to go every 2 hash marks here. So this would be, for me, my pi over 2, and that's just kind of personal preference to kind of stretch it out and use the whole space. This would be pi. This is 3 pi over 2, and then this would be 2 pi. Okay, and then again on my y-axis, again, I just kind of want to use up that whole space there. So instead of me putting 1 right here and having that graph be really squashed, I'm just going to label my 1 value actually as like up here. Okay, so that's 1. I'm going to do the same distance down below, and I'm going to call that -1. As long as you label it, I don't care where you put it. I mean, obviously it has to make sense numerically, right? But try and use up that whole space there on the graph. And now we just plot our points. I'm going to start with 0, 0. Plot our point at 0, 0. Pi over 2, comma 1. Pi, comma 0. And then 3 pi over 2, comma -1. And 2 pi, comma 0. Okay, all these points are exactly directly from the unit circle. They are the y values on your unit circle at that angle measure. Okay, so now I'm not going to create a little like zigzag here kind of thing with straight lines. The sine curve is a curve, so we are going to make some sort of S curve as best as we can, okay, where we're going to go up and then kind of down like a little parabola here, and then again make another parabola kind of facing the opposite direction, okay? So I've got a little S curve going on here. And that is my sine curve from 0 to 2 pi. Now again, this is just one part of it. It continues this pattern forever and ever and ever to the right and to the left. And there's a word that we use to describe this, specifically this distance, a full cycle going through all 5 of those points. We call this a period. So this whole thing right here is a period of my sine graph. Okay? So again, it does continue in both directions. I'm just drawing a little sketch here. This is definitely not perfect, but you get the idea. Okay, so if I'm talking about the range of this function, range is that my x or my y values for range. Range is my y values. So what is my range of this function sine of x? -1 to 1. The lowest value is -1. The largest value is 1. Okay, my domain of the entire function sine of x, not just this period right here, but the domain of the entire function is going to be what? Yeah, -∞ to infinity. It goes forever and ever in both directions. Okay, but parentheses around those because we can't ever touch those values, right? And now your range might change depending on, you know, this distance right here. This might not always be 1 right here. It might be stretched or shrunk or shifted or things like that where it might affect the range. But is anything ever going to be able to affect my domain of this function? No, because it's going to continue to go forever and ever in both directions. Okay? Wonderful. All right, so before we actually talk about examples 1 and 2, I want to go to the next page really quick and talk about those transformations that you guys have seen before in Algebra 2. But before we talk about them, I've got 3 examples up on the board here of different transformations that are happening, and I want you guys to talk with the people sitting next to you about what is happening with these 3 functions right there, okay? About what transformations are happening in this. So go ahead and talk to your neighbor right now. Our flashback from Algebra 2 of what happens to all these things if, this is a generic thing, right? If we have a number a, and this number is being multiplied by my function, if this number is bigger than 1, so like if it was 4 times my function, that's going to be a vertical what? Stretch or shrink? Is it going to stretch it or is it going to shrink it? Stretch. So this will be a vertical stretch. If it is smaller than 1 but bigger than 0, so in between 0 and 1, excuse me, that is going to be a vertical shrink. And I forgot one thing on there. If a is negative, so if we have a negative a, that's going to flip it how? Is it going to flip it across the x-axis or is it going to flip it across the y-axis? It's going to flip it across the x-axis, yep. So it's a, not horizontal. It's a reflect over the x-axis. Okay, now I didn't actually have any of these up here, so you might not exactly remember, but if you have a number on the inside and you're multiplying it with that x, if it's inside those parentheses and it's negative, instead of it reflecting over the x-axis, we're going to reflect across, what do you think? The y-axis. And now if our number that we're multiplying it by on the inside is bigger than 1, if it's bigger than 1, we're going to actually have a horizontal shrink. And then if it's in between 0 and 1, it's a horizontal stretch. Sometimes that's a little harder for people to see, so if you want to play around on Desmos with that and see kind of what that looks like, if you put a different number on the inside of that parentheses there, you can see how that shrink and stretch kind of happens. And then the last one are pretty easy for us to see. If we're going to take a function and add or subtract a number on the outside, what am I doing? What's happening with my graph? It's moving up or down, so it's a vertical shift K. Right, if it's plus or minus K, it shifts in that direction. And then if I've got H on the inside, so if it's like X plus 5, we're going to shift it which direction? Left 5, right? So it's going to be a horizontal shift. H. But I am going to put a little note here. Remember to think opposite when you are graphing this. Okay, because if it was X plus 5, I'm not going to shift it right 5, right? We're going to shift it left 5. So it's always opposite of kind of what your brain thinks, okay? All right, now we're going to go back and finish graphing those sine function graphs before we move on to cosine. Okay, so using what we just talked about with those vertical stretches, horizontal stretches, all that kind of stuff, we're going to use that idea, and we're going to use the same points that we were given in order to graph our new functions. Okay, so our first one is y equals 3 times sine of x. So what is that 3 doing to my function? It's stretching it, right? So this is a vertical stretch. Of 3. Now, if I'm stretching something, is that going to affect my x values or my y values? My y values. So my x and y points are going to be the exact same, except for the y is going to be stretched by 3. Okay, so we're going to multiply it by 3, whatever my y value was originally. Okay, so my x values, we're going to continue the same. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, my original y values from my sine function up above were 0, 1, 0, negative 1, and 0. However, I need to multiply all of those by 3 because we're stretching it by 3. So this now becomes, well, still 0 actually. What does 1 become? 3. 0 becomes 0. Negative 1 becomes negative 3, and 0 is still just 0. Okay? Now, you could think about plugging it into the function if that makes more sense. Like if I wanted to evaluate y and I wanted to evaluate it at pi over 3, do 3 times sine of pi over 2. I said pi over 3, I meant pi over 2. Okay, so I can evaluate this, right? Sine of pi over 2, we already set up above. Sine of pi over 2 is just 1. So then I would have y equals 3 times 1. So I get 3. Okay, so you can think about plugging it in every single time to get your output. However, if you always remember your parent kind of 5 points there, your parent function 5 points, you can just use those transformations and apply that instead of having to like think through the unit circle every single time. Does that make sense? Okay, so now I just got to plot these points on the graph. if I plot these points on the graph, I'm going to label my x-axis with 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, I like to kind of go by twos here. So this will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm just going to plot those points. Again, I'm going to try and take up kind of as much space as I can on this graph. So I'm going to label 3 all the way up here. I'm going to label negative 3 all the way down there. And I'm just going to plot those points. 0, 0, pi over 2, 3, pi 0, 3 pi over 2, negative 3, and then 2 pi, comma 0. And do my best to draw a little sketch here of my sine curve. Not perfect, but you get the idea what's going on. And if you kind of look comparatively to the one that we just did up above, obviously our scales are a little different, but do we see the stretch that's happening there? Yes? Wonderful. Again, my period, if we're talking kind of a little vocab here, my period is still 2 pi because it goes through the entire 5-point cycle. Okay, your period will not always be 2 pi, but in this case, it is. One other vocabulary word that we'll put up on the other page, but I want to show you what it looks like on the graph, is the word amplitude. Okay, amplitude is your distance from your maximum or minimum to that midpoint of the graph. Okay, so this distance right here and this distance right here, they're both the same, right? And that distance would be 3 in this case. So my amplitude is 3. My period is 2 pi. If I look at the previous graph here, what would my amplitude be of this graph here? Just 1. My amplitude is 1. Very good. Okay, we're going to try example 2, and then we're going to look at Desmos. I'm going to let you guys kind of play around and see how things affect the graph before we move on to cosine. Okay, we've got sine of 3x. I'm actually going to change that to just be a 2x so that it's easier a little bit mathematically for us to think through these things. Okay, and if it's in the parentheses, this is one that's kind of a little bit more difficult to think about. If it's in the parentheses, if you look at that table that we just filled out, is it going to be a horizontal stretch or a horizontal shrink? It's going to be a horizontal shrink, okay? It's kind of the opposite again. If it's in the parentheses, it's kind of the opposite of what you think it should be. So it's going to horizontally shrink this stuff, which means is it going to affect my x values or my y values? It's going to affect my x values, right? If we're taking something and we're shrinking it, that's going to affect my x values. Okay, so I'm going to write down my original xy function here for sine and my values that go along with it. 0 pi over 2, pi, 3 pi over 2, and 2 pi. And then we've got the values of 0, 1, 0, negative 1, and 0. So if we're shrinking or stretching things vertically or horizontally, what do I do with those numbers? Am I multiplying? Am I adding? Am I dividing? What am I doing? Yeah, we're going to be multiplying, but since we're shrinking, right, instead of multiplying by 2, we're going to think about the opposite of that. We're actually going to divide by 2, right? Because if my period is from 0 to 2 pi, I want that to shrink, right? A horizontal shrink of 2, which means we're going to divide all these numbers by 2. All of my x values. So 0 divided by 2 is going to give me 0. If I take pi over 2 and I divide by 2, if you need to write that out, that's okay. Pi over 2 divided by 2, or times by 1/2, right? What's that going to give me? Pi over 4. Take pi, divide by 2, that's an easy one, pi over 2. If I take 3 pi over 2 and I divide by 2, or times it by 1/2, what do I end up with? 3 pi over 4. And then lastly, 2 pi divided by 2 is just going to give me pi. Okay, another way to kind of think about this is instead of it being from 0 to 2 pi, like we've normally had it, right? If I just made this from 0 to pi, I can find out my other values by just, again, dividing by 2. If I take pi and divide by 2, I end up with that pi over 2, which was our middle point. If I take pi over 2 and divide by 2, I end up with pi over 4. How could I find this third point here? Well, I know it's pi over 4 more than pi over 2, so that would be 3 pi over 4. Okay, so we need to be able to kind of think in these fractional points. So I think if we're going pi over 4, this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, right? Which is exactly what we got over here on my table. Okay, so those are my x values. Questions on how I got those coordinate points. And then my y values are exactly going to stay the same. Okay, so I'm going to plot the 0, 1, 0, -1, and 0. So I'm going to go ahead and label my 1. We'll do 1 at 3 up and 3 down. And then I can go ahead and draw my points. Okay, one thing I want you to note here is that is my period 2 pi? No. What is my period going to be in this case? Just pi. Okay, I go all the way through all 5 points in the distance from 0 to pi. What is my amplitude in this case? 1. My amplitude, that distance all the way back to that x-axis there, that would be a distance of 1. So, we talked about the translations and transformations already. This is your general kind of formula for sine and cosine with some variables plugged in here, where like we have a number on the outside, that's what we're going to call our a, and then we could have a number on the inside before the x and a number outside of that. We're going to talk about what all those things mean. Today, the main focus is being able to identify what A does to our graph and being able to identify what the D and like the plus C is doing to our graph, okay? Because today we're not going to have any B values in front of our X unless it's just by itself, okay? So our A, our absolute value of A, that is our amplitude. We've talked about that a few times already. So this A, that's also your vertical stretch. But if your A is negative, what's also going to happen? It's gonna flip where? Over the x-axis, right? Okay, this plus D that's on the outside of my function, if I'm adding something or subtracting something to that, that is going to be my vertical shift, up or down. Sometimes that plus D or minus D or whatever is going to be in front of your function as well. So just be careful if it's being added to the sine function or added as the cosine function. That is where your vertical shift happens. Almost everything that we've done, that you have done, I should say, in Algebra 2, when you were doing things like, little side tangent over here, like graphing functions like x squared, right, graphing parabolas and things, you were only ever really given things like this. You were never given anything with like a number in front of this, like that, right? So normally it's only a horizontal shift for this one. It'd be a horizontal shift left one, right? But this one is not going to just be to the left one because I've also got a 4 in front of here, okay? So how you basically, what's the word I'm looking for? How you adapt or change that, I guess. The formula for it, okay, is this thing right here. It's negative c over b. So it's taking this value and this value, and you're dividing those, and that is what you shift by. You horizontally shift by that thing. So that's your horizontal shift. We're not really going to get into that today. We'll get into more of that next class. And this is actually called a phase shift, is what you'll hear it be referred to more so. And then we talked about the other kind of new vocab word we've talked about is period. And period is, again, going through those 5 points on your unit circle all the way through. Sometimes that's in just 2 pi. Sometimes it's going to be less than that. The way you find it is by taking 2 pi and dividing by this b value here. So we will do that, not today, but you will see it next class. Okay, but that is the formula that you will use to evaluate it. So these kind of 4 formulas here are things that you will want to have memorized by the time a quiz and a test comes up, okay? Question on those things? Okay, now we're going to look at cosine, okay? So if you don't remember your cosine values of your unit circle, you might want to kind of go back and forth between this page and the last one. But we're going to use the same x value. So I'm going to use the same 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, but now on my unit circle, I'm going to be thinking about all of the x values because cosine is my x value at that certain angle, okay? So if we're at 0, what is the x value going to be at 0? 1. So my y value is 1. At pi over 2, what is my x value going to be? 0. At pi, my x value there is going to be negative 1. 3 pi over 2 will be down at 0 there. And then 2 pi all the way back around, we're going to also be at 1. Okay, so do you see how using that unit circle helps us get those points pretty easily? But those are the only kind of 5 points that you're going to need to know. So you don't really need to know like the square root of 2 over 2, things like that. But we do need to be able to know which one's sine, which one's cosine of these points. Okay. So let's go ahead and plot these on our graph here. So on the x-axis, I'm going to label, I got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, now this is our function cosine, so should cosine and sine look the exact same? No, there's going to be some sort of change, right? So when I'm plotting my points, let's say my y value of 1, we'll call it here, and we'll call negative 1 here. So when I plot these points, sine started at 0, 0. The original sine function without any shifts or anything starts at 0, 0. But for cosine, we're going to actually start at 0, 1, okay? And then at pi over 2, we're at 0. At pi, we're at negative 1. 3 pi over 2, we're at 0. And at 2 pi, we're at 1. So this is not an absolute value graph, even though that kind of does look like what I just drew there, okay? We do need it to be a curve still. Now, instead of it looking like that S curve that we had on the previous page, it's going to be kind of looking like a little, like, valley in between two mountains. Okay, so try your best to kind of make it a little curvy there instead of just straight connecting the lines there. Okay, this period, what would I call this period right here? It goes through all 5 points with a period of what? 2 pi. Okay. Now, sometimes on your homework, it might say things like, I want you to graph y equals cosine of x, but on the range from negative 2 pi to 2 pi. Okay, what that means is we just drew the graph from 0 to 2 pi. So how would I change it so that it's all the way from negative 2 pi to 2 pi? Yeah, I just need to like reflect it over and make the same thing, right? So I could label these points over here as negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. And if you think about this from a unit circle perspective, negative pi over 2 just comes straight down here. So my cosine value of this would be 0, right? So it's going to give me those same values as I have on the other side, just reflected over that y-axis. So at negative pi, I'd be down here. At negative 3 pi over 2, I would be at 0. And at negative 2 pi, I would be at 1. So if I connect all of these lines here, this would be your graph of cosine of x from the interval negative 2 pi to 2 pi. Okay, you can figure out the first part and then just reflect it over to find that second part. Does that make sense? Yeah? Cool. Okay. Let's see. All right, now we're going to do some transformations with my cosine. Oh, I forgot the range first, though. Range and domain. Domain, same thing. It's going to keep going forever and ever and ever in both ways, right? So my domain is going to be negative infinity to infinity. And then what is my range of my parent function cosine of x? Range is my y values. So what can I range in between? Negative 1 and 1.
Why is it negative 1 first?
Always the smallest number first.
Okay.
Yep. So if I would change this, though, and if I put like a 5 in front of this, what's that 5 going to do to my graph?
Sorry.
No, you're good. What's that 5 going to do in front of that cosine? It's going to stretch it, right? So then would my range still just be negative 1 to 1? No, it would become negative 5 to 5 because you're going to stretch all of that by 5. Okay? All right. Moving on. 2 more examples. Okay. This one I've got cosine of x plus pi over 4 in parentheses here, and we're graphing it over just one period. Okay? So think back to your algebra 2. What is this plus pi over 4 going to do? It's going to move it left 4, or sorry, not left 4, but left pi over 4, right? So left pi over 4. So that means, is it going to affect my x values or my y values? X. So let's go ahead. I'm going to write all of my x and y coordinate points from the cosine value first, and then I am going to change it after. Okay, my y values are not going to change at all. But what I would like you guys to do right now, because sometimes fractions are hard for us, go ahead and subtract pi over 4 from all of these values for your x values, okay? Make common denominators, and then rewrite what your new x coordinate is going to be to the left of them. Okay, so I'll give you a minute. Subtract pi over 4 from all of those values. What is your new x value going to be on your graph for cosine of x plus pi over 4? Hopefully we got pi over 4, negative, oops, and then pi over 4, right? And then this one would be, what's pi minus pi over 4 going to give me? 3 pi over 4. 3 pi over 2 minus pi over 4. That one's a tricky one. 5 pi over 4. And then 2 pi minus pi over 4, that's going to give me 7 pi over 4. Do we agree? Make common denominators, write it out if you need to, but we will need to be able to think in terms of fractions this unit. So, okay, now I can go ahead and graph these things on here. Okay, so we're going to go by pi over 4s because we got a negative pi over 4. So I'm going to start over on the left side as negative pi over 4 here. And then I'm going to have a positive pi over 4 on the right. And then I've got 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, we'll call this my 1 up here, -1 down there. And I can just go ahead and plot these points. So I'm starting at 1, I go down to 0, and then I go down to -1, up to 3 pi over 4. Oh wait, what did I do?
You don't have 0, 0 anymore.
Ah, thank you. I was like, something is wrong. Okay, so then I need to go here. My scale's a little off. What am I doing? This needs to be here. And then this needs to be at -1, 0, and here. Why does that look weird?
Because your left one is too far left.
You're right, it is too far left. I like made this be pi over 4, but then everything else was pi over 2. Do you guys see what I did there? Yeah? So let's change this. Well, and this one technically. Ah, poo. Okay. Well, this is annoying. Because then if I can't just make that be. Okay, I'm just gonna fix this real quick. I'm just gonna erase that real quick. And I'm gonna make this negative pi over 4. I was off by like just one little tick mark, and then it was looking weird. Yes. Okay, that looks better, right? And now I can go ahead and plot my points. Not there. Here. Okay. Better. Scale looks a little bit better there. It looks a little bit more accurate. And now I can go ahead and connect my points. Make my curve. And this is my cosine function, but it's shifted left pi over 4. So like your first probably 10 questions on your homework are going to be giving you a bunch of different graphs of just cosine and sine, and it's going to be showing you either shifting left and right or vertical stretching, and you're going to have to be able to match which one goes to what, okay? Alrighty, question on this one? Okay, last one here. We've got y equals -2 plus cosine of x, but we're doing this over 2 periods. Okay, so we're going to find it first on the right-hand side, and then we will move it over on the left-hand side as well. Okay, so what does that -2 do to my graph? Be careful, because where is that -2? Is it attached to the cosine?
Oh, no.
No. So the -2 only does what? Could I write it like this? If I wrote it like this, would it be easier for you to tell me what to do? It moves it down 2. Do you see how the -2 is not attached to the cosine? So it's not actually going to be a stretch and a flip. It is just going to be a vertical shift down 2. Okay, so my kind of parent function again for my cosine values, I'm going to plot those on here first. So I've got 0 pi over 2 pi, 3 pi over 2, and 2 pi. And then all of my y values of the 1, 0, -1, 0, and 1, those are all going to be shifted down 2. So what am I going to do with all those values? Subtract 2. So this would become -1. This becomes -2, -3, -2, and -1. Okay, so on the x-axis, I'm not going to mess it up this time. I'm starting at 0, and this would be pi over 2, and this would be pi, 3 pi over 2, and that one is 2 pi. And then I'll just label this as let's see. Oh, I could go by 2. So this will be -1. This will be -2. This will be -3. Your scales might look slightly different than mine. That is okay. And I'm just going to plot these points. So I've got 0, -1, pi over 2, -2, pi -3, 3 pi over 2, -2, and then 2 pi -1. Okay, so I can connect all these points here. Your period here is still 2 pi. What is my amplitude in this one? It's shifted. Is my amplitude from the maximum to the minimum point, or is it the maximum and minimum point to like the midpoint here? Right, because technically, like, this is my normal graph if I shifted it up to, right? So my amplitude is only that maximum or minimum point to that, like, midline. Okay, so what would my amplitude be here?
1.
Yeah, it's 1. So amplitude is 1. Okay. Okay, that is just one period, so I need another period. I could either go to the right, but the way that this graph is right here, we don't really have space to go to the right, so I'm going to go to the left, and all I'm going to do is completely reflect this over that y-axis. So this is going to become -pi over 2, -pi, -3 pi over 2, and -2 pi. And then I'll just reflect those points across. So at -pi over 2, we are at -2. At -pi, we're at -3. At 3 pi over 2, we are at -2. And then at 2 pi, we are at -1. So I can connect all these points here. And that would be my cosine graph. So y equals -2 plus cosine of x. And then it is over 2 periods, or on the homework you might see from -2 pi to 2 pi. Okay, that means I want you to graph that sine or cosine graph over that entire interval, and then stop. Okay. Questions on this? It's a little different. It's a little tricky, but do we feel okay about it for the most part? Okay, so again, your homework is about 20 questions of matching. They aren't too terrible because it's only really doing 1 or 2 transformations. And then you have about 3 questions where you're actually going to graph the actual function by hand like we were doing here. Okay, so I'm going to give you guys about, let's do like 3 minutes of break, and then I'm going to show you guys the John Baylor video session 4. It's 20 minutes long, and then whatever time we got left over, you guys will have time to work. Okay.